So today I will talk about vector product to the area and the volume, that how vector product related to the area calculation and volume calculation. So first of all, let me talk about dot product, because vector product is of different types. I will talk about a few things which are related to the volume calculation, the area calculation. So vector product, we will categorize this as like dot product, vector product, scalar triple product, and vector triple product. I will talk about only dot product, vector product, and the scalar triple product, because this scalar triple product is related to the volume, and this vector product is directly related to the area calculation. So before moving towards vector and the scalar product, let us have a brief review about the dot product. So what is a dot product? This is a very important concept. Generally, when we talk about dot product, means if we are having two vectors, one vector is A and another vector is B, and both the vectors are making an angle theta with each other. Say both these vectors A and B are making an angle theta with each other, then their dot product is mathematically represented like this, and it is defined as the magnitude of first vector and magnitude of another vector and cosine of the angle between them. So this is known as the dot product. This is the mathematical definition. There is another way to look at it. Say if I draw a perpendicular from, let me take this diagram again. So if I draw a perpendicular from B vector to A vector, then this distance is basically what? This is basically B cos theta, because the magnitude of B vector is this one B, and this is B cos theta. Because if I say try to look at this O PQ, if I consider a right angle triangle OPQ, then this side adjacent to angle is OP upon hypotenuse is OQ, then it is nothing but it is cos theta. So from here I can write down it as OP is basically, OP comes out to be OQ cos of theta. OQ is nothing but this is the magnitude of B vector. And there is also very another interesting thing which we have to see. See if I put a source of light here and it casts a shadow, because if I put a source of light over the head of B, then it casts a shadow. This one, this is the shadow region. So that means this is the projection of this B vector along A vector. Means this shadowed portion is nothing but it is the projection of, so that means I can write down it as the magnitude of A vector and magnitude of B vector and the cosine of theta, and this is nothing but this is the projection of vector B along vector A. This is what is B cos theta, and this is the magnitude of vector A. This is basically rather than, let me write down magnitude of vector A, right? So this is the product of these two quantities. We can also look at this in a different manner also. Let me again took it from here, and if I again draw a perpendicular from this, so this is the perpendicular of this, then ORS. So in OSR, right angled triangle, OSR, then adjacent side is OB, over hypotenuse is OA, OR. It is nothing but it is equal to cos of theta. So I can write down it as the OB is equal to, no, sorry, not OB but OS. This point is S, sorry, it is a V vector. So OSR, so it is OS rather than it is B, it is OS. Let me correct it later. Yeah, so it is OS, and similarly I have to correct it here also. So it is OS is equal to OR cos of theta, and this OR is nothing but it is the magnitude of vector A cos of theta. So this can be written in the other way, like A cos of theta. If I put it like this, then both are the one and same thing. So I can write down it as it is the, because if I put a source of light here like this, then it casts a shadow. This is the shadow region. This is the shadow region along vector B. So this is the length of that shadow region, because if I put a source of light over the head of this R point, so it is the projection of vector A along vector B multiplied by magnitude of vector B. So this is another way to look at the dot product, right? So in terms of Cartesian coordinates, if we want to write down the dot product, then how that can be represented. So let us have a look at that. Means now dot product in terms of Cartesian coordinates. So suppose there is a Cartesian coordinate system. So in this system, let us consider two vectors. One vector is this one and another vector is this one. And these two vectors are making an angle theta with each other. Say it is vector A and it is vector B, and say its components are AX, A by AZ, and its components are BX, BY and BZ. Now this A vector is represented by AXI cap, AYJ cap, AZK cap. Similarly, vector B is represented by BXI cap, BYJ cap and BZK cap. Then how this dot product can be written? It can be written like this, means AXI cap, AYJ cap, AZK cap. It's multiplied by this BXI cap, BYJ cap, BZ k cap. So it is axi cap, it is multiplied by with whole of this vector b. So bxi cap, byj cap, and bz k cap. Similarly, this y component is multiplied with all these, so it is plus byj cap, bxi cap, byj cap, and bz k cap. So very simple. And similarly, bz k cap, it can be written as bxi cap, byj cap, and bz k cap. So then what will happen? Let me try to look at this part first of all. How to operate this? So it is basically ax bx I cap dot I cap. This part can be represented like this. Similarly, I can write it down this ax by I cap and the j cap plus ax bz I cap and k cap. So what is the angle between, because I cap is along x-axis, say I cap is along x-axis, this is I cap, just a minute. So this is I cap, this is j cap, and this is k cap. These are along the three mutual perpendicular vectors directions. So what is the angle between I and I? It is 0. So it is ax bx cos of 0. Because the magnitude, because I dot I is what? I dot I, the magnitude of it is 1, and cos of 0, and cos of 0 is 1. 1 into 1 into 1, it is equal to 1. So it is cos 0. So that's why I should write down this quantity as, using this concept, this is equal to 1. Means when x is multiplied with the x component, its value comes out to be 1. Its value is 1. But when I is multiplied by j, so I is j, it is 1 into cos of 90 degree, because there is a 90 degree angle between I and the j cap. So and cos 90 is 0, so 1 into 0, it makes it 0. So when a unit vector is multiplied with itself, it remains 1, but if it is multiplied with another unit vector which is perpendicular to it, then its value will be 0. So that means this value will comes out to be 0, this value also comes out to be 0. So that means here in this part we will remain only with the quantities, which is ax bx plus. Similarly, when j is multiplied by with I, so then these are again perpendicular, its value comes out to be 0. But when j multiplied with j, it will remains the same. Oh sorry, I have mistaken somewhere here. Yeah, it is rather than this, it is a y and az, right? So it is when y with y, so it is a by b by. Similarly, and it is az bz. That's what is the dot product in terms of Cartesian coordinates, right? So next comes out to be this what we call a scalar product, or the cross product, or the vector product. Dot product is also known as scalar product. Then another is a very important quantity, that is the vector product, vector or cross product. So what is it? Suppose we are having two vectors. Say one vector is this one, A, and there is another vector which we call it as a B vector. So what is the cross product? The cross product is basically defined as A cross B. It is equal to magnitude of each vector. It is the product of magnitude of each vector and sine of the angle between them, and it is always pointed along a direction which is perpendicular to the plane containing both A and B. Suppose let me do little more, or let me draw two new other diagrams in terms of Cartesian coordinate system. So it is a Cartesian coordinate system, and in this Cartesian coordinate system, say it is a three-dimensional coordinate system. So basically in this coordinate system, let us say that it is a vector A and it is a vector B. Means it is x-axis, it is y-axis, and it is z-axis. It is a z-axis. So that means when a vector is lying in the xy plane, a vector in xy plane, and b vector also in the xy plane, then what is n cap? N cap is always along z-axis, because n cap is always perpendicular to, n cap is along a direction which is perpendicular to plane containing A and B, because both A and B are lying in the xy plane. So that means n cap is along z-axis. This is a way to define a cross product. This is the one way to look at it. So what does it mean? That means A vector is rotated towards B in the clockwise direction. In the counterclockwise direction. Means A is rotated along B in counterclockwise direction. Then A cross B is pointing towards z direction, positive z direction. We call it as a positive z direction. But when B is pointed towards A, then it is, means when B is pointed towards A, then it will become B cross A. Then it points in the opposite direction. It points along the negative z direction. Right? So that's what we have to take care here. So that means this B cross A, it can be represented as magnitude of both the vectors, sine of the angle between them, and it is the minus n cap. So from these two equations we can conclude that this A cross B always equal to minus B cross A. Also, let us try to look at it, that how it represents the area. So let us do one thing. Let us consider a vector A is along this direction and vector B is also along this direction, and let us complete a parallelogram. Also, the magnitude of this length is from here to here, it is A, and its distance will be, it is B. It is B1. It is B. So if I try to look at this parallelogram, and it is made from two vectors A and B, then what is its area? Say it is O A B O P, rather than O A B, let us call it as O P Q R. So what is the area of the parallelogram? Parallelogram, it is equal to what? It is equal to either parallel side and multiplied by perpendicular distance between this pair of, means the parallel side which I have taken here, and the perpendicular distance between this pair of perpendicular lines. So that means if I am considering this OA side, so that means it is OA into perpendicular distance is this one, let us call it as a OPQR, and say it is S. So OA into RS is basically this one. Or rather than writing it in terms of this cross product, let me do it like this. It is OA into RS. This is the area of a parallelogram. If I try to look at this, what is OA? It is magnitude of vector OP. So it is vector A, and say if these are making an angle theta, so what is this distance? If I try to look at this triangle, a right angle triangle, that is OSR, then SR over OR is equal to sine theta. It's simple trigonometry I am applying. So SR is equal to OR sine theta. So I can write down SR as equal to, because this OR is nothing but it is the magnitude of B vector, so it is magnitude of B vector sine of theta. So it is B sine theta, right? So this is it. So that means what A cross B represents, it is basically what? It is the magnitude of cross product. So thus area of a parallelogram is basically equal to magnitude of cross product forming that parallelogram. This is a way to look at this what we call area. This is a way that how area can be calculated. So I think that's all for today. In the next lecture I will talk about that how area of a small element can be calculated, and after that I will talk about that how vector triple product is related to volume element. So thanks for watching this lecture.